Here's a little trick I discovered accidentally a couple years ago when I was doing videos here. A special effects thing that you can do, you know. Now you see me? You don't. Now you don't. It's like The Leftovers on HBO series. Here 1 minute, gone the next. And I'm back, just like that. Alright, let's finish chapter 3. This is the very last part. It's about ecosystem disturbances, and you can find it on page 73 in your book. Ecosystems respond to disturbances. A disturbance is anything that has an effect or upsets an ecosystem. It may have an effect on the different types of species that are in that ecosystem. It may have an effect on the abiotic factors of the ecosystem. For instance, soil erosion, something along those lines. Natural disturbances happen. They're weather phenomenon, tsunami, tornado. Of course, for us, we have hurricanes, volcanic eruptions. These are natural disturbances that in environmental studies we deal with. But disturbances can also be man-made, anthropogenic. For instance, clear-cutting a forest, or even clearing land so that you could farm would be a man-made disturbance. We can talk about mining, air pollution, or even if we're just clearing land so that we can build a new neighborhood. These would be anthropogenic or man-made disturbances. These disturbances can be studied by scientists. For instance, we studied watersheds to see the effect that can happen in a man-made disturbance. I'll show you a diagram of what a watershed is. This is an important concept for you to remember. A watershed is all of the land area that feeds into some low-lying body of water. In this case, it's a river. Could also be a lake or a pond. And you can see all the way up in the forests, even as high as the snow-capped mountains, all of this water eventually, by gravity, ends up flowing down to its lowest point, and in this case, it's a river. That's a watershed. They can be smallish, a few miles wide along the length of the river. It can be very, very flat and huge. The watershed for the Mississippi River extends west from the Appalachian Mountains and east from the Rocky Mountains. All of those middle states are all part of the Mississippi's watershed. Now you need some terms to understand disturbances, and we will use these terms throughout the year, so learn them now. The first one's called resistance. Resistance is the ecosystem's ability to ward off a disturbance. Its ability to resist the problem. When we talk about resistance, we're talking about the ecosystem's ability to keep the energy flow going and also to keep the biogeochemical cycles going and also to keep a high species diversity. That is to say, lots of different species. Resilience is the ability of the ecosystem to respond to a disturbance. Some ecosystems can bounce back very quickly. For instance, if there was a water event, a flood or something, the species leave because they go to higher ground, but then later on they return as the water subsides. That would be a relatively quick turnaround, so that would say that that ecosystem has high resilience. We're talking about the ability to come back like within a year, for instance. That's called resilience. Restoration ecology is, the study of ecosystems and how they come back, and our use of human activities to try to restore an area. We just learned about one. Do you remember? That's right, the Florida Everglades are an example of restoration ecology, where the Army Corps of Engineers is putting a great deal of investment dollars and man-made structures in place to try to restore or bring back the Everglades. Another great example that we'll talk about later in the year is the Chesapeake Bay area. For 20s of years, 20, 40, 60 years, the Chesapeake Bay has ended up with pollution in it because it is at the end of the line of many, many rivers. So all of those rivers, with all of the pollutants, all of the things that have been dumped into those rivers, all end up in the end at the Chesapeake Bay. Well, we've recognized that fact, and now we're taking steps to try to clean up the Chesapeake Bay area. We'll talk about this intermediate disturbance hypothesis. It's an interesting concept because it's kind of counterintuitive. What I mean by that is, one would think that an ecosystem that has a disturbance once in a blue moon might not have very good resilience. And we find that it does not have very good resilience. But if it only happens once in a blue moon, one might expect it to come right back. Well, that's not really the case. Here's the graph that kind of depicts what we're talking about here. If you're an ecosystem with infrequent disturbances, they're rather severe, and because the ecosystem isn't used to dealing with such a disturbance, it takes a long time to come back. The intermediate disturbance hypothesis says that ecosystems that have an intermediate amount of these things, that is to say they don't happen frequently and they don't happen once in a blue moon, well, these places have a tendency to be able to bounce back. Generally, this is because species have adapted, or the soil is such, or the landscape is such that species are able to come back and the area returns back to normal relatively quickly. But this graph is also showing us that, and this should just make sense to you, when an ecosystem has frequent disturbances, it's very hard for that place to come back and have a good high amount of biodiversity. Ecosystems that do not have very good resilience, sometimes it's an abiotic factor like soil, for instance. In the example that they used in the book, an area that experiences an extreme drought will have its soil dry out. Well, if its soil is dried out, when it does have a rain, that soil is so hard and compacted, it cannot absorb the water very well, and the water just runs off. And in that case, the soil never really gets moistened to the level that it should, so it dries out even faster or stays dry, and it's an example of a positive feedback loop, because now the soil really can't hold moisture. It's harder and more compacted than ever, and then the next rain happens, same thing, water runs off, it never really hooks up to or adds water to that soil. Ecosystems provide valuable services. Here are some more definitions that you need to understand. When you look at these terms, you should understand exactly what we're talking about so that you can speak to them either on an AP exam on an ACE, or on an ACE exam. Instrumental value, you can see from the word instrument, means that the ecosystem provides value to us because we can use it for something. It has worth because it enables us to accomplish a goal. An ecosystem with good instrumental value, for instance, might be a place where we grow trees so that we have lumber, or so that we can make paper. That would be an example of instrumental value. Ecosystem services are an instrumental value that we sometimes don't think of. Certainly when it comes to provisions, we do think of that. We think of the many things that an ecosystem provides to us. Wood from the forests, rubber from trees. There's a lot of prescription drugs whose base is in plant life. These are examples of provisions. Even food could be considered a provision, some ecosystem service that's provided to us. Regulating services are more about what happens in the environment. For instance, water is cleaned as it slowly infiltrates down through soil and recharges our aquifer. In that way, our water is being cleansed. It's a regulating service. In some cases, we have regulating services. An example would be carbon dioxide in our atmosphere. It turns out, even though we pump billions of tons of carbon dioxide into our atmosphere every year, it turns out that the Earth does have some ability to heal itself. A lot of that carbon dioxide ends up being absorbed into the oceans, for instance. We talked about that with the carbon cycle. So even though we might pump 8 gigatons of CO2 into our atmosphere, when we measure how much CO2 is in our atmosphere, it is about 4 gigatons. So we're showing, the Earth is showing its ability to regulate itself, even though anthropogenic sources are causing problems. We already talked about resilience in terms of ecosystems, and we talk about the ability of an ecosystem to come back. Cultural services are sort of just like it says. You know, there are cultural aspects to our lives in which ecosystems provide a role. It may be a certain food that's part of your culture, and the ecosystem provides that. Intrinsic value is the last of these values. Many people believe that ecosystems aren't valuable just because of what they can give us, what they can do for us, but they are also valuable just because they are. They have intrinsic value. They have value in and of themselves. And because they have this value, we have a responsibility as the top of the food chain, only species with the ability to think and reason. We have a responsibility then to protect and take care of these ecosystems. That's intrinsic value. The ecosystem has a value just because it is, just because God put it here. Okay, I think that's about it for chapter 3. Bring me your questions, bring me your thoughts. I'll be happy to hear them. Good luck.